The first thing is the midterm exam. Midterm exam will be the Friday, 9:30, not this room. It's Dana Hall 107, where you did the engineering 400. Then the exam hour is the same as the class hour, 9:30 to 10:45. In case we need the time, I don't think we need the time. I make the exam question very easily. So as I suggest the last class, so you can study based on the class activity. Okay. So and the textbook and other classroom material. So that's probably enough. I know the textbook is almost 300 pages. 200, 300 pages, but that is the last way, but at least you need to study the class material, including any homework project, and so any class activities will be helpful to prepare your midterm exam. Then you will have the spring break. But those who have the conflict schedule, I already informed that will have the makeup exam after spring break. So I do not have a time to have the makeup exam before that. So unfortunately, the makeup exam will be the after spring break. That is the first announcement. The second announcement is for the project zero grading. Some of the students got the 0 mark in case so not follow the requirement of the project zero. Okay, I clearly mentioned the several the requirement. So in the project description, if that is not satisfied, seriously, then there is a 0 mark. Also, if GAME found any, I do not care who is the original one or who copied, as long as we find the same copy, same submission, all of them. Okay, not only 2. So we found the several, the exact same source code is a 0 mark. Okay, so you don't have to argue this is not my fault. Okay, so as long as it's just the same copy, same the submission, is all of them will get the 0 mark. Okay, so do not argue. So I'm the original one and he copied or she copied. So that's not an issue. Okay, it's the same policy for the rest of the semester. So this is a project zero, so which means it's warming up. So you realize that it's a small portion comparing to other. I probably consider the 25% to 30%. The project is 30% to the 40%. Total out of 100 marks of the final grade, then among the 30 to 40%, the project zero will be like less than 20%, maybe the 10% is warming up. Okay, so there is no the makeup chance. Some of the students would like to submit it again. No, there's no other the second chance to cover. Instead, focus on the main. We have 2 more, the main project, so you can focus on that, the 2 main project. Okay, then try to follow the requirement. It's not a programming competition in this class. It's not the programming course. Okay, so you don't have to spend a lot of time just the graphical user interface or the decoration. No, so focus on whether you can convert the requirement or algorithm into the programming. Okay, in other words, the algorithm will be the main portion of the whether you implement correctly, accurately the requirement and algorithm or not. That is the main part of the project 1 and project 2. Then read carefully the project description. Okay, so in case of the project, so I mentioned this several times. The Java will not be considered in the project zero. So because the Java basically used the thread instead, we'd like to practice to create the process and implement their communication using system call and system library. I mentioned many times, several students just use or the refer the existing the source code from textbook or internet and use the Java. At that time, it's marked as a 0. Okay. So this time, no excuse. So because this is a warming up, so it will not hurt the seriously. Okay, it's a small portion of your the project. So but this time I'm not going to give the second chance. So instead, try to enhance and focus on the project 1, the project 2. Then consequently, the third announcement is our project 1 is due on after spring break, so end of March. So during the spring break, you can spend more time. So I think that most of them are from, except the 1 or 2 students, but even the non-computer science major student, it cannot be excused. I do not have background in programming because this course requires the prerequisite of the programming. Okay, so which means it cannot be considered or it cannot be excused even though you are from the electrical engineering or not. Definitely, computer science student or computer engineering student already complete the prerequisite, which means the basic programming languages is 101, 102, 390, or the 500 object-oriented programming. So it will not be considered whether you have the background in the programming or not. So that is the announcement. Then I think that you can enjoy the spring break. After spring break, we will continue the lecture. So today we are going. This is not part of the midterm exam. Midterm exam will cover chapter 1 through chapter 6. For your reminder, so exam format is less than half. I think this time the fully 15 questions for the multiple choices. I think the 15 questions for the multiple choices. Each question is worthwhile. The 3 point is going to be the 45 point, and the other are open-ended question. Okay, which means it's like the quiz. So you can answer, or you can justify, or you can list, or sometimes you can describe. Okay.
How many other questions? How many other questions?
I cannot remember. Probably 4. Less because you have the 1 and 15 minutes. So less than 4 questions, but maybe 5. I cannot remember. But toward the 55. Okay. Any questions regarding to the exam?
The subjective part questions will be based on the programming or concepts?
I do not ask the specific code in my class, ever. But pseudocode may be possible. Okay, pseudocode means the algorithm in terms of the algorithm. Okay, so whether on a semicolon that cannot be considered as a question. Okay, but the pseudocode may be possible, but I'm not going to ask the specific code of in terms of programming. Okay. Any others? I think that if you take those who are in this class right now are very diligent, and hopefully you will get a good credit. So in the midterm exam. Then after I finished all the makeup exam after spring break, then we will quickly check your exam sheet. I will hand out, and you can check. And then if there's any issue or problem, then we can adjust your grading. Okay, then we will continue the deadlock problem. So last time we have seen what is a deadlock. So deadlock will be happening the blocked process. Okay, the process are blocked. Which of them is holding other resource, then they request another resources is held by other process, then at the time they cannot proceed the next instruction. So that is called the deadlock, the problem or deadlock event. So we characterize such a deadlock. So in terms of the 4 requirements, the first one is the mutual exclusion, and for one way, no preemption mostly is the circular weight. Circular weight is the most dominant feature that can characterize whether this is deadlock or not. So today we are going to use the circular weight to detect the deadlock. However, not always the circular weight cause the problem of the deadlock. We will see such an example. So to formalize such a resource and the process, the graph and the process, the situation. So we are going to use the resource allocation graph, RAG. When in my dissertation, PhD dissertation, I have used the same name of the graph RAG, but that was not the resource allocation graph. I have used the adjacent graph. Okay, so it's actually the region adjacent graph. So interestingly, it's the same name. But anyway, so for example, these are the notation of the resource allocation graph. Process will be represented by the circle. There are two types of node. One is a group of process, another one is a group of resource. Each resource is a resource type, so it may be possible each resource type have the multiple instances. So because of such a multiple instances, sometimes we have the circular way, so it may not cause the data. Okay? So if the edges from the process to the resource type is a request, otherwise it's the assigned. Okay, so we have seen such an example of the resource graph. Then, so we try to solve the address such a deadlock problem. So we have seen the four of them. Among the four of them, we took a look at the two of them first. So that is the deadlock prevention and deadlock avoidance. Both of them the prevent the operating system never cause the deadlock. Instead, before the deadlock, we try to prevent or avoid. So first, the deadlock prevention. The requirement of the characteristic of the deadlock is the mutual exclusion, hold and wait, no preemption, and circular wait. In other words, if we break the one of the requirement, it may not cause deadlock, right? So that is the idea of the prevention. However, deadlock prevention not always the possible. Okay, so it's ideally possible. Sometimes practically not very possible. So that is the deadlock prevention. Deadlock avoidance. So we try to avoid the deadlock in case of the request. Instead, before operating system, the permit the request. So check whether this request cause the deadlock or not. So to decide, we are going to use the safe state of the operating system. Safe state means there is no deadlock. Okay, there's no hold and wait, there is no circular way, so it can be, all the process can be terminated successfully. So that is the safe state. Otherwise, if we cannot find any sequence of processes that can be terminated successfully, that is unsafe state. So before operating system assign the resource to the process request to check whether this is unsafe or safe state. So how can we check? So using the Banker's algorithm. Is there anyone who researched why it's called the Banker's algorithm? I did a long time ago. There's no specific reason, but the Banker's algorithm is kind of fairness, right? In case of a lot of customer in the teller, so they try to assign, to take care the customer by each the teller. So that is that is the reason I think. So it's the Banker's algorithm. So using the Banker's algorithm, so this I ask you, as your homework probably, to understand the algorithm of the Banker's algorithm. Safety algorithm is based on the Banker's algorithm, but it looks like the complicated, but it's using the example is very simple. Our goal is to find the list of the process, which means the finish will be all of the finish. All of the process will be true. How? So we try to allocate we try to find the processes that their need is less than the available. So that is the idea of this Banker's algorithm. For example, we have seen the 3 resource type and the 5 process cases. So we have the allocation, max, and available. So available is right now is available. It can be assigned any of them, and the max is to be completed. That is each process needs this amount of the resources. So 7 of A, 5 of B, and 3 of C for P0 and so on. Allocation indicate allocation matrix indicate the each processor already have this amount of the resource. So using this one, we know how many of them are needed, so we can calculate the need. So need is the max minus the allocation will be need. So we can calculate how much more need. So for example, P0 is a 7, 4, 3, and so on. Then our goal is to find the process, first process, that is all each resource, all of the resource type is less than the available, that will be terminated. So that will be the process. Then in case that is done, each process is done, there all the resource type will be returned to the operating system, which means the available, it will be added to the available. Then if we can find all the list of the process, that will be the safe state. So in this case, this is a safe state. Then the problem is the process will request some of the resource type, then the check whether this will be deadlocked or not. In other words, whether if we allocate the permit to assign the request to the process, whether this is the safe state or not. So in this case, the process 1 requires that this amount of the resource 1 over A and 2 over C. Then it will be allocated to this one, then available will be reduced. Then we will apply the same algorithm, Banker's algorithm, to check the safe or unsafe state. Then successfully we can find the P1, P3. Is that the only sequence? No, there might be many of them, but at least we can find one, a sequence of process, it will be safe state. So I think that I gave the homework. What about this one? You don't have to submit. I believe that all of you did this homework at home, right?
Yes.
Yes. So what about the other? We did the last time this one. What about this?
No, I didn't do it.
Is it safe? Unsafe? I will check it the final exam. Okay? So why don't you try? That is, I think the most of the algorithm that we have discussed or that we are going to discuss in this classroom is not very complicated. The algorithm class is much easier than this. The problem is that this is a practical application of the algorithm that you have learned in any other subject to the operating system application. So understanding the algorithm is different from to applying to the real life example. So please practice by yourself. Okay. So to do that, we assume that this one will not the previous one. In case we allocate this one, whether we can find the sequence of the process that can be terminated. If you can, that is a safe state. So operating system permit to allocate such a requested resource. Otherwise, the decline the request.
Professor.
Yes.
What does it mean? Can request for P0 be granted? Does that mean that the first request should be for P0?
The P0. Not from this one, the previous, the state, okay, from here. This is a current state. So current is a safe state, right? Okay. Then in case the P0 requests a 0, A2 over B, okay, request additionally, okay. So then whether this one caused the deadlock or not. So that is the question in this case. So in this case, the operating system will not enter any deadlock situation, okay? To avoid, before that, the operating system check it. So this is a deadlock avoidance. The problem, whenever any resource or a request of the resource, operating system check, run this algorithm, okay? So if you have the simple operating system, like the embedded system, it's okay, but in general system, I don't think so. Okay, so also we will see other algorithm and how we can apply such a deadlock, the deadlock, how to address the deadlock, the event in the operating system. The third one is a deadlock detection. So far, deadlock prevention and deadlock avoidance, the operating system never enter the deadlock event. However, this one, so because whenever the operating system, the processor requests request a new resource type, the operating system needs to check this overhead. So why don't we let the operating system allocate accept any request? Okay, not all the requests cross the deadline. Only few, actually, very few of the requests may cross the deadline, the situation deadline event. So we allow any request. Then periodically, from time to time, check whether current state of the operating system is a deadlock or not, whether safe state or unsafe state. So to do that, we need to detect the algorithm. How to detect the algorithm? We can apply the same algorithm, Banker's algorithm, to check the current state is the deadlock or not. Okay, so that is the deadlock detection. So to do that, the best way is if we are going to use the resource allocation graph. So how can we detect the deadlock from the resource allocation graph? Our goal is to find whether any circular weight or not, whether it's a circle or not. By the way, how to find the circle from the graph? Process.
Waiting for the resource.
Yeah, so this is a resource allocation graph. This is a graph structure. Then our problem is whether we can find such a circular weight, circle or not in the graph. Then problem is this, we can simplify the problem. Can we find the circle from a graph structure? So therefore, this is the circle in the graph, right? And also this include such a thing, right? And this is not. Okay? So how can we? Yes, we can do that, but there is no optimized solution, which means we need to check each and every node. It will be n squared. Okay, brute force way. Okay? That is it fast in terms of the Vigo notation? It's a worst case, right? It's a very worst case, so it's a exponential graph. So at least it should be n log n. Linear is very nice, and also the logarithm is the best case. At least it should be n log n, but this one is n squared. So there is no the optimized solution, which is called NP-hard problem, non-polynomial, the hard problem. There are existing solutions that can be optimized in graph theory to search this one. But at the time, they try to provide the constraint or the feedback. Okay? By considering this is a special type of graph, then we try to find something subgraph match. It's called a subgraph. Searching or matching, it doesn't matter. So subgraph is usually NP-hard problem, no optimized solution, but nowadays there are many. The optimized solution, which is less than n squared, the complexity. So at the time they try to consider some of the consideration. Nowadays, the graph theory, graph matching, graph operation are very important. Because of what? Facebook, social media data. So you have heard about the data analytics, data science, data something. So actually, the main reason why we have such a boom of the data analytics is the social media data, and one of the easiest and best way to structure such a social media data is graph. It's intuitively, we can understand this is kind of the social media site, like the Facebook or follower, the tweet or the Flickr. So the main idea of the social media website is that we try to make a friend. Then we try to give the comment or like or follow. It's a relationship. Because of that, it's right now everybody use crazy for the social media data. Then, if we can use such a graph for the social media data, there are a lot of things we can solve. For example, who is the opinion reader? Can we find the node, like the concentrate or the kind of centrality? It's called the centrality analysis. So can you find such a leader that can be connected, many of them? Okay? And also, can I find probably the Facebook graph will be huge graph. Can we find, this is the example of the customer, okay, for example, or the Facebook user who lead the opinion. So we can call the influence user. Can we find a similar user from other graph? So subgraph matching and or search. So this is the one of the top research topic in nowadays as a graph. And also, but beyond that, we have used a lot such a graph matching. So this is one of the problems. So, which means it's a very expensive operation to find. So, instead we are going to use the Banker's algorithm again. So, Banker's algorithm, I don't think that's the optimized solution. It's also kind of good because we will see the big complexity in terms of the big notation later. So we are going to use the same the variable as we have used before, the variable and allocation and request. Okay, then the detection algorithm is basically same the mechanism as the safety algorithm. We have seen the deadlock avoidance. Okay, so we will see the example. So this is the current state. So in the deadlock detection, we are not going to check we are not going to block to allocate the resource to the processes. So just allow. Then from time to time, run the detection algorithm. So this is the current snapshot. Okay, this is the current snapshot. So which means there are no available resource, and the P0, for example, allocated this one, and total, there's no other request. Okay? So at that time, can we complete all of this process?
Can complete P0.
So for example, there's no more request. Okay? This one, P1 needs 2 of A, right? 2 of C, but there's no available. So this will not be possible. But P0, there's no more request, which means it can be terminated. They already got all the resource currently. So this may be possible, and also this one will be possible. This one is not, this one is not, because we do not have any available currently at this moment. So either of them will be fine, yes.
P4 is not possible?
P4, this one needs 2 more, of C.
It's the request, not the maximum.
It's not maximum. So they need maximum probably does the same thing as a safety algorithm, but different notation. Okay? So that's the reason it's called the detection algorithm. If we add up this one, that will be max in terms of the safety algorithm. Okay? So in this case, both of them can be terminated. So we can start. Actually, we can start from the P0, P2. Then check the other, because both of them can be completed. So, but why don't we follow this order? So whether that is possible. So P2 is the first. So 303 will return to the available. Okay. Then the P3 need 1 more of this one. So it is possible. So 211 will be returned. 211, 514. So this can be terminated. And next P4, 2 of the C, so it will be returned 516. So this one is done. And P1, yes, definitely. And finally 2 of 2 is less than this, so it will be returned. So we can find the sequence of the process at least 1. So because then we can not detect any circular way, any problem of the detection, so country is okay. So we can find many other the sequence, so it's not a problem. At least if we can find at least one of them, this is safe state, so there's no problem. However, so let's say the P2 request the additional instance of type C, so P2 request. So in case of the detection algorithm, the operating system allow any instances. Okay, so which means the P2 request one more, but currently there's no available. Okay, it's a request is permitted, so you can get it if you are available, but there's no available, so then check whether this is a deadlock or not. Then this is not possible because you need one more, the C, so only the P0 will be possible. So P0, then this one will return 0, 1, 0. So P0 is done. Which one? Anyone available?
No one.
So we have only one of the B. So this one is the 2 of A. So this is not possible. This one need 1 of C. This is not possible. 1 of A, not possible. 2 of C, not possible. So because of the request, so this is the unsafe state. So there should be deadlock.
Yes.
There may be, okay, we don't know. So this one detect only the circular way by considering other. So in general case, there may be possibility it can be completed, okay? So not always a circular way is the deadlock situation. So it may be, but the conservative, so we consider this is a deadlock, then to do something. We will see how to address the deadlock problem. Okay, yes.
Why we are not sure it's a deadlock? Why we are not so sure it's a deadlock?
This one, we consider this is a deadlock, but in practical, the situation, not always this kind of deadlock detection can detect only the deadlock, in general deadlock, because it's based on this case. So if we have the other, this one would like to detect the circular weight only. So it may cause the deadlock. In this case, it's definitely deadlock, but in general case, even though we can find, we can detect that this is the unsafe state, but this is not always the deadlock, but we regard this is the deadlock situation, then do something to address it. Okay, so then how can we address the problem? In case we cannot find the sequence of a process, so deadlock may exist in the current state. If we allow the P to 1 over C, then how can you address? So there are several solutions. The best way is, in case you are waiting the library book, you are holding another book, you are holding another book, but the request each other. Best solution is kill one of them. Then the book will be available. Or expect the student. Then the book will be available then give it. So that is the easiest way in operating system. That doesn't mean it's the best way. Okay, so what if he's the best student of the school? He's the worst student. So or he doesn't pay any tuition. So it's the same thing in the operating system. It's we'd like to that is the best way to kill one of the process. That's called the victim process. We'd like to find the victim process, then the kill such a process, then that the terminate process, abnormally terminate process can restart. Okay, so but problem is how can we determine the victim process? He may be he may feel it's not fair right? So there are several things we can consider. What is the victim process? When we terminate the process, we can consider priority of the process. That this student has a higher priority than him, okay? Because he is handsome than him. So we can consider most of them are the priority based. So in this case, explicitly we can use the explicitly assign the priority, or longer is the higher the priority. Or so the process who consume the more resource is the higher priority, right? It's so funny. Sometimes in a bank, so if the customer loan a lot of money, then the customer sometimes consider valuable. The VIP customer, really, instead of the customer who put the money in the checking account a lot. Really. Because he pay the interest and the in terms of benefit, okay, of the bank, is better than the checking account. So the more research the process you use, then it can be considered as the higher priority, okay? And so on. Then problem is any of the priority-based algorithm starvation, which means in this case, it may be possible certain process can be terminate all the time. So we need to consider what is the best way of addressing the starvation problem or the priority-based. Async is one of the solutions. If terminate, okay, then the promote the priority, whatever the priority is here. Okay, so we can select the victim. Our goal policy is the minimize the cost. Okay, then start it again. Okay, then however, in this case, we need to be careful to avoid the starvation problem. So in general, so we have the not only just one of the deadlock prevention is not practically possible. We can consider some of them. What about the commercialized current operating system? The Linux or Windows, how do they handle the deadlock event or deadlock situation? They ignore. That doesn't mean there's no algorithm to handle the deadlock. Yes, it is. If you take a look at the Windows API in the Windows system, they have the deadlock, the event deadlock manager. Okay, but such a deadlock manager is from application level or your programming level deadlock, not operating system. Why? Operating system does not care the deadlock. You probably happen not nowadays, but the Windows XP or the Windows Vista when sometimes your operating system stops. Okay, nothing changes. Your application is not proceeding to the next instruction. At the time, you can Control C. What is a Control C, by the way?
Kill signal.
It's a internal. It's a signal, sending the signal to the operating system. Okay, explicitly the stop. Okay, so who is in charge of handling such a deadlock? It's a user application. That is a general in any operating system. The reason is that we just discussed before. Mostly, it's an NP-hard problem to detect the two or avoid the deadlock. Okay, so in case we have the 100, 200, 300 processes and a lot of resources, so it's not easy. But comparing to the overall, the event and overall operating system, deadlock event is a very few. It's less and less and less. So some of the research, the manager actually trying to avoid such a deadlock or provide more the available resource or share the resource, and we also consider some synchronization or the transaction, okay, to address such a problem. So because of that, we have less and less deadlock event. That if we learn, the algorithm itself is not optimized yet. So it takes a longer time, it needs overload, and it's a downgrade the operating system. Instead, why don't we just ignore the number of events of the operating system that application user will be in charge of such a deadlock event. However, so in your application level, you may encounter such a deadlock event. So if you are doing the multi-threaded programming or the multiple processor program or application, you may encounter that if you want to detect such a deadlock, the operating system provide the API, I do not know Linux, the pthread or the green thread algorithm, but the Windows from XP, they have the deadlock manager. So in your application level, so you can detect whether my application program has a deadlock or not. So that is the current approach, how to handle the deadlock event in the operating system. Okay. Any questions? Don't care because it's not part of the material. Okay. I think that this semester we have the very good math students, so I think the progress is faster than the usual. So I like it. Okay,
They're not asking too many questions.
Which way?
Students are not asking too many questions.
I don't think so. I can. So whether or not you have the question or not, so I can feel whether the student can understand the lecture. Okay. So sometimes I need to explain again and again and again. So, but also we have a lot of students. So I prefer to have the classroom quiz, the pop-up quiz, or the solving the problem in the classroom, but the practical is not possible this semester, so I actually skip that part because of that we have the available time. But the second part, I will use such a pop-up quiz. Most of students don't like such a pop-up quiz. You like that? Okay. So that's the first half of the topic that we plan. That is the process management. So as we have discussed at the beginning of the semester, there are three main parts of the operating system. So before that, so how many core courses do you have in computer science or computer engineering? I think it's slightly different. I think the majority of this class is computer science, right? So how many core courses? You have the 5. One is programming courses. So it's true. So without programming language, we cannot implement our ideas. So definitely we need a programming language. Regarding to the programming language, it has been changed. So when I learned the computer first time, it's a COBOL and the Fortran. Then slightly C program language, but most of my colleagues and friends gave up, including me, to learn the C program when we learn the pointer. So the pointer is one of the first the hurdle to overcome when you learn the C program. So, but anyway, so that is a programming. Any other core course? Advanced database. This one, operating system, algorithm, and networks. This is it. Okay, this is it. These core courses, I believe is. What about the computer architecture?
It's not just kind of.
Oh really? Yeah. What about the computer engineering? There is a core course for the computer engineering. Let's consider computer architecture also. So computer architecture. So these are the basic courses that usually when I consider such a basic course or core courses in the computer science and engineering, it's like the human body. Okay. So our main goal of the learning computer stuff, computer science and computer engineering is like the mimicking the human activity. Okay, that's true. So we try to develop and make the machine like the long time ago calculator, starting with Leibniz calculator. Then the 60, 70 years ago, there is a huge size of the computer. Why do we need such a thing? We try to have the human calculation of the number and to solve the other problem. So in terms of that, so like for example, program language is like our natural language for the communication. We want to communicate with the machine stuff, like the computer hardware. And the computer architecture is like our skeleton, and it's the anatomy of the human body. So how the computer is organized. Then we need on top of the operating system. Like this. So operating system, one of the important, is kind of in between. Anyway, the computer should serve for the human being. That's true. Otherwise, I know the robotics nowadays is changing. But anyways, the computer should serve for the human being. So in terms of that, operating system is the in between such a machine and the user. Okay, so that is because of that, I believe the operating system is in addition to the computer architecture in CE, computer engineering. So operating system one of the most important subject in the computer science and engineering. So even though my major is in the database, so database is one of the core courses also. It's getting the important nowadays. However, whenever I has been asked, how can I be a database administrator? How can I prepare like the certificate of the database analytics, database administrator, database the architect? At the time, I asked them, why don't you study other core courses, including operating system? I know not all of you guys will get a job to develop the operating system. Maybe nobody. However, operating system is the basic subject, okay, that can address it can be applied, not only just applying this algorithm to the application, but whenever you encounter the problem of the computer-related stuff, without understanding the operating system, yes, you can do that. You can do the programming, but if you can understand like how the deadlock is caused and how the semaphore is working, how we can use the monitor, what is the synchronization problem, what is the transaction, okay, eventually. If you understand such a thing, definitely you can design your application, software, not just a developer, you will be engineer, software engineer. So that's a huge difference. So many of the students ignore the importance of the operating system. So I'm not interested to develop. No, even I never developed the operating system. However, so when I learned the database first time, so my manager asked you should know your computer first, because database itself, it's just an application. If somebody asks which one is more important, definitely operating system is more important than database. Database you can do that later. Are you going to learn how to use the Microsoft Word? No. It's just an application level. As long as you know how to click and how to right click, you can learn. So database is the next step. However, if you understand the computer architecture and the operating system and the programming, then the DCC and the database and other elective courses, it's not a big problem. But to do that, algorithm is also another important step to understand any kind of subject. Okay, so to continue such an importance of the operating system, the second part will focus on the memory management and the I/O management. So these, unfortunately, so far the UB enrollment is not stabilized. Even though we have a lot, I don't think we have continuously have such a high enrollment. Sometimes in the near future it will be dropped and will be stabilized. Because of this one, so we cannot separate the undergraduates. There are some undergraduate students in operating is closely listed. So I keep asking the department to focus on the advanced part of the operating system. This class that include nowadays virtual machine and distributed operating system So you probably heard about the big data and the big data system. That is based on the distributed the file system. So that should be actually discussed in the gradual level, the operating system. But because of the current curriculum, we need to cover the basic. Still, the main memory is the important subject in our operating system. We will continue this one. But hopefully this semester, if we can complete the subject earlier, so we can discuss more. Okay. What time is it now? Let's just stop today's lecture here. Okay. Then